Histograms for beginners. A histogram is a graph representing the frequency of data points using bars. The x-axis shows the data point intervals and the y-axis the frequency that data points appear in the intervals. A histogram is useful for showing how common or rare a certain value or interval in a dataset is, and it allows us to see the shape of the distribution. Here are some examples of data points. They could be attributes such as age, height, and shoe size. They can be measures as used in BI, for example, sales and count, or they can be the value of a dependent variable for those in the experimental sciences. I also wanted to draw your attention to the fact that histograms are only used to represent numerical, not categorical data. For categorical data analysis, bar charts are more suitable. Since the data points are numerical, they have intrinsic order. So, when sorted, they form a range, from the minimum to the maximum data point value. However, the range of the histogram extends beyond the max to include the last value, but this will be explained later. On the x-axis, we show the intervals of data points. Intervals are groups of data point values, and they are also called buckets, bins, or classes. Intervals are segments of the histogram range. In this video, we will only cover equally sized intervals. However, it's also possible to divide the range into differently sized intervals. You can get more information about this in the video about uneven bins. When we talk about even intervals, it is clear that the number and size of intervals are related. The greater the size of the bin, the fewer bins fit in the range. Interval edges are the lowest and highest value that is included in an interval. It is important to note that the left edge of each interval is included, while the right edge is not. Let's imagine we have interval edges of 1, 2, and 3. Let's see into what interval the data point 1.7 goes into. Okay, this was easy because this value falls between 1 and 2, so it would be in the first interval. Now, a trickier question. What interval does the data point 2 belong to? If we remember that the right edge is not included in an interval, it means that the data value 2 falls into the second interval. Let's look at some considerations for making intervals. The first rule is that all data points must fit into the intervals. The first consideration for making intervals is that all data points must fit into the intervals. Let's see what we mean by this with an example. Let's imagine that some shoe company wants to determine what sizes of shoes are more popular to better manage the stock. Some data analyst decided to build a range for the histogram based on the min and max shoe size. Do you think he is correct in choosing this range? Although it seems intuitive to just construct a histogram by making the leftmost interval edge 5 and the rightmost edge 13, this would exclude all shoes that were size 13, because they would fall on the rightmost edge, which is not included in any interval. This is where the enigma x comes in. We need to add the smallest value that the granularity of the dataset allows, or more, to the maximum value. The point is that we need to make the range big enough to fit all the data points while being evenly divisible by the number of bins. In our case, let's make the range bigger by adding 0.5 to the max. 0.5 is the smallest increment shoe sizes come in. Now the problem of missing shoes of size 13 in the histogram is solved. But is adding 0.5 enough? Let's see what happens next. The second consideration is that the edges of intervals need to match the granularity of the dataset. So let's get back to our shoe size example. If we decide the number of bins is to be 3, the bin edges turn out more granular than the data point granularity. What does a shoe size of 7.83 even supposed to mean? I guess it would look something like this. This means that we either need to increase the histogram range to make it divisible by 3, or we can increase the number of intervals. If we increase the range by 0.5 again, we make it evenly divisible by 3. So this problem is solved. Now we are ready to formulate the algorithm for the calculation of interval edges. The first step is to decide the number of intervals. The chart is easier to read when the number is between 5 and 20. However, if your goal is to better perceive the shape of the dataset, sometimes an even greater number of intervals would work better. Step 2 is to determine the histogram range, following the rules stated before. Step 3 is to divide the histogram range by the number of intervals. This would give the size of intervals. If the granularity of the size of intervals is inappropriate to the granularity of the dataset, choose a number of intervals and the histogram range that results in a cleaner interval size. Lastly, to find the interval edges, we add the interval size to the min repeatedly until we reach the histogram max. Each of these intermediate numbers would be the edges to each interval. Let's talk about the frequency, which is on the y-axis. Frequency is measured as the absolute value or as the relative frequency, which is expressed as a decimal or percent. Once we have divided our range into intervals, we can count the number of points that fall into each interval. This would be the absolute frequency. To verify if done correctly, see if the sum of the frequencies add up to the total number of data points in the dataset. We can now represent the frequencies as the bar whose height corresponds to the number of data points in each interval. Alternatively, the frequency can be represented relative to the other intervals. For this, we need to divide each absolute frequency by the total number of data points. To verify, make sure that the relative frequencies add up to 1. Now we can label the y-axis with the decimal values or the percentages. Shape of distribution. Keep in mind that regardless of how the frequency is represented, whether it's an absolute value or a relative frequency, the shape of the distribution will not be changed. This is because we're only changing the y-axis labeling. However, relative frequency labeling may be more meaningful for datasets with large numbers of data points, or in cases where the absolute numbers are irrelevant. What does change the shape of the distribution, however, is the interval size. The distribution will become more granular or completely change when the size of intervals is decreased. Here I have divided the range into 6 intervals instead of just 3. And here I have drawn the histogram for this range. The distribution has shifted and we can see different trends surfacing. The graph seems much different to the graph we got with only 3 intervals. To examine and interpret the shape of the distribution of histograms, please refer to the video about shape of distribution. Now that you know how to build a histogram with equal bins, you may also be interested in these topics. Thanks for watching. This video is part of my Data Analytics Statistics course. Subscribe to see more of this type of content.